Hi, Jason and Joe. It was a pleasure chatting with you both yesterday. Here I am in the WileyPlus online teaching and learning environment. Specifically, I am in the assignment section. I've created a small assignment with two problems right here for students. These are Go tutorial problems. Joe was telling me that one of the biggest challenges in his class is helping students understand how to properly go through the process of solving a problem. And these Go tutorials in the Halliday Wiley Plus Orion course are designed specifically to help students with that. So this is a problem from the magnetism chapter 28 in the book. And you can see the problem here. Potential energy U of a magnetic dipole and an external magnetic field B as a function of angle theta between the directions of B and the dipole moment. The vertical axis is set by U sub S is equal to 1.9 times 10 to the negative 4 joules. Dipole can be rotated about an axle with negligible friction so as to change theta. Counterclockwise rotation from theta equals 0 yields positive values, theta and clockwise rotations yield negative values, and so on. So the question wants you to find the maximum value of theta for which it will rotate. So if you go here, students at this point, if they're adventurous, can choose to solve the problem directly and enter their answer, which has a tolerance of plus or minus 2%. And then the units, which is a nice feature that we've added that really forces the students to choose the correct unit for their answer. Assuming I'm a student that really doesn't know where to start, this Go tutorial, which Go tutorials are found for 20% of the questions in the text, so that number has increased. So let's pretend I have no clue where to start with this. So if I click on the Go tutorial, it opens the Go tutorial, which indicates here that it will provide you with a step-by-step guide on how to approach the problem. The Go tutorial consists of 6 steps, and you can see here that it tells the student what problem it is. And I attempted the first part myself. You'll notice here that I got it wrong because I didn't put it in an answer. But it goes through the key ideas. The potential energy U of a magnetic dipole located in a uniform magnetic field B is given by U equals negative B cos theta, where theta is the angle between the two vectors. So the second key idea right here, and it tells you getting started from the graph, what is the potential energy of the field dipole system when the dipole is released. So again, I didn't know the answer, but it allows me to check my input if I did have an answer. And then you see if I click next, it gives you the second step that you should follow. Find the product of the coefficient times p. So again, put your input in. Assuming you get it right or wrong, you can go to the next step. What is the mechanical energy at the moment of release? So again, asking students to think about the things that are important in the process. Next step, 1.4, what is the mechanical energy when the dipole reaches the maximum angle? Again, taking the students through the fourth part of solving the problem. The process, okay, so again, going through the process. Fifth part, you can see I tried it, got it wrong, so it highlights in green. And again, the last part of the Go tutorial, what is the potential energy when the dipole reaches the maximum angle theta? And that would be the final answer. Again, checking the input, I didn't put anything wrong, so I got it wrong. But you can see here, assuming the student does get it right, it says now that you know how to solve the problem, go back and try again on your own. So with these Go tutorials, which is the most popular feature in this Halliday WileyPlus Orion course, you can see how students are given a step-by-step way to understand how to solve the problem.